Good morning, everyone. So today we're going to be talking about writing equations of lines. And what we've been doing in class is we've really been talking about graphing lines and finding the slope of lines, meaning the ratio to the horizontal change versus the vertical change. But now we're going to be writing equations of lines. And why is this important? Well, writing equations of lines helps us to describe the line. So I can use that description, so to speak, to graph the line and to do some other things with the line that I may need to do. Now, there's a very big difference between finding the slope of a line, which is a formula, right, which is a ratio of the horizontal change, so the change in y over the change in x. The change between points on a line is your slope. Writing an equation of a line is one of those three equations we talked about. We've talked about the slope-intercept equation, which is in the form y equals mx plus b. We've talked about the point-slope form, which is y minus y1 equals m times x minus x1. And we've also talked about standard form, which is ax plus by equals c. Well, the good news is we're actually not going to write equations of lines in standard form. You can't go directly to standard form. You can put equations into standard form from slope-intercept and point-slope, but you can't actually write an equation in standard form. So the good news is we're going to be using these two forms. Now, we want to be efficient. We want to decide which one of these is better. And I know a lot of you are very tied to slope-intercept. But remember, slope-intercept only has one very special point that I can use for it. That special point is the y-intercept. Remember that 0b is the y-intercept. So I really only want to use slope-intercept equation if I have that very special point. It's just not efficient. Point-slope, on the other hand, I can write an equation of a line in point-slope if I have a point and a slope. So any point. So this one we want to get a little bit more tied to. All right, so let's talk about a couple of things. There are some minimums we need. I like having my minimums. At a minimum, to write an equation of a line, you need a point and a slope. If you have those two things, then you can write a line equation. If you have the y-intercept, that's even better because then you can jump right into slope-intercept. But again, we want to look very carefully for y-intercepts. We would be looking for 0, some y value. Okay, so we're only going to want to use slope-intercept if we see that. All right, so here's our first example. It says, write an equation for the line with the slope of 2 that contains the point 3, 1. So I want you to note you were given a point and a slope. So if I'm given a point and a slope, then the most appropriate equation to use would be point-slope. So first, what I want everyone to do every time until we get good at this is write the equation. Y minus y1 equals mx minus x1. Now in every slope equation or every equation of a line, there's going to be an x and a y because that's my input and my output. So here's my input, here's my output. The x1 and the y1 actually refer to this point. So if it helps, put x1 and y1 above your point. The slope is 2, so I'm going to write m is 2. And all I'm going to do is substitute those values in for those particular, I need my pen, sorry. For those particular points, okay? So watch me do that now. All right, my m was 2, so I'm going to put it right in here. I'm going to leave my x, and then my x1 was 3, and my y1 was 1. And I'm going to put in my equals. Okay, now you could put this in parentheses if you want, but it's not necessary. All right, now I want you to notice something. Look, the 3 here was positive, but I put it in the equation. I'm plugging it in right here. The y1's goes right in here, so those signs are not going to change. All right, so that's really all you do if you're given a point and a slope. And you can say that that's your final equation. Point-slope form. All right, I want you to try. So I want you to press pause, and I want you to find an equation of a line with a slope of 7 that passes through the point 3, 4, following the exact process I just did, okay? So press pause. Okay, so you're back, and hopefully you first wrote your equation. Y minus y1 equals m times x minus x1. You labeled your point x1, y1. You wrote down your slope of 7. And then you substituted those values into the formula. So y minus 4 equals 7x minus 3. Perfect. Point slope form. All right, let's move on. Let's try a different example. What if I ask you to write an equation of a line that contains the points 1, 3, and -2, -3? So I'm given 2 points. Well, that's when I have to ask myself the question, what's the minimum I need to write an equation of a line? What's the minimum? What's my minimum? Look above. My minimum is I need a point and a slope. Not just a point, I need a point and a slope. Right now, I actually have 2 points. So I'm going to pick one of the points. I got a point. How am I going to get this darn slope? Well, this is where the slope formula is going to come into play. We need to do the change in y over the change in x. We have to find the slope. All right, so remember, as a formula, that is y2 minus y1 over x2 minus x1. These points are this is my x1, y1. This is my x2, y2. Okay, I'm going to plug them in. So -3 minus 3 all over -2 minus 1. Got to be very careful with my negatives and my positives. So I have a -3 minus 3, which gives me -6. I have -2 minus 1, which gives me -3. If I simplify that, the negatives cancel and I get 2. So now I have a slope of 2. Now the great news here is I can pick either point. I tend to always pick the positive value. All right, so then I plug it in directly to the formula. So y minus 3 equals 2 parentheses x minus 1. Now, students often ask me, do these parentheses here matter? Yes, they do. Okay, and so we've got a final equation in point slope form. Now, I know, again, you want it so badly in y equals mx plus b, but this is a perfectly acceptable way to write an equation of a line. We're going to talk about how we can put that in y equals mx plus b or standard form a little bit later, okay? All right, I want you to try. So I want you to press pause and try this equation. All right, so you're back, and hopefully the first thing you recognized is that you had 2 points. And you realized that the minimum you needed was a point and a slope, right? Because that's what we need to write an equation of a line. So you found the slope. So you did change in y over change in x, which is y2 minus y1 over x2 minus x1. Now, and I also see it says a line. So when we think lines, I want us to think that we need slopes, okay? All right, so I did 6 minus 7 all over 2 minus 5, which is -1 over -3, so my slope was 1/3. Got my slope, gonna pick a point. I picked 2, 6. You could pick 5, 7, doesn't matter. If you picked 2, 6, you would have done y minus 6 equals 1/3 parentheses x minus 2. If you did 5, 7, you would have done y minus 7 equals 1/3 x minus 5. All right, guys, so that's how we do it if we're given 2 points. All right, let's look at if we're given a graph. Write an equation of a line for the given graph. What I love about a graph is that it gives me a little bit of information. I know without a doubt that if the graph goes through the y-axis that I have the y-intercept. So right here I can see I have the y-intercept. So that's my B. So this is one of those cases that I'm going to, that's even better. I can use y equals mx plus b. I can use slope-intercept form. So I'm going to write that one down. When given a graph, this is usually the easiest one to use. So I find that, and then I find another index point so I can find the slope because I still need a slope. Still minimum I need is a point and a slope, okay? So I found an index point right here. So I do the change in y, which would be down 1, and the change in x, which would be 1, 2, 3, 4, 5, which was the right 5. I put my change in y over my change in x, which would be -1 over 5. And then I write down my y-intercept. So my b would be, or my y-intercept would be 0, -2. Now, all I have to do, and I'm going to change colors so you can see it, all I have to do is substitute those values directly into this formula. So negative 1/5 x minus 2. Nice. Okay. And we're going to be doing some more like that. But again, given a graph, usually the easiest one to use, as long as the line goes through the y-intercept, would be slope-intercept. Hopefully you're seeing why I feel like each of these is like a more efficient way to write the equation of the line. Remember, an equation of a line is not a slope. It is the description of the line so that I can graph it. Okay, the last two we've been talking about a lot. Writing an equation of a line with a zero slope or an undefined slope. Okay, so zero slope. This is one of our special lines. Remember, the two special slopes are zero slopes and undefined slopes. So as soon as I see one of those special slopes, zero slope, I'm going to think hoi vux. Hoi vux. Okay, so I know that zero slope, this is just my reminder, my helper. Zero slope tells me it's a horizontal line. If it's a horizontal line, then the equation is only going to have one variable, and it's going to be y. So y equals. I look at the point I have. Hopefully you recognize that the important point for you would be the y, so 5. So my equation, y equals 5. No harder than that, but you do have to remember the difference between horizontal and vertical slopes and their lines. All right, here's another one. Write an equation of a line with an undefined slope that passes through the point 2,5. Okay, that's one of my special slopes. I know that means my equation is only going to have one variable. I remember hoi vux, used for undefined. That means that it's a vertical line going up, down. And its equation is going to be x equals some number, only one variable. I look at my point. Hopefully you see that the x coordinate would be the important point, so my equation would be x equals 2. Very important for you to remember that horizontal and vertical lines only have one variable. They're one variable equations. All right, guys, hopefully that was helpful. Tomorrow we're going to be practicing in class. Make sure you bring your computers because we're going to use Desmos.